Okay, welcome folks. Hopefully we are live on YouTube now. This is the latest installment of the virtual Cloud Native Manchester meetup. Joined today by my co-host Nick Jones and two special guests, Jürgen Etzlstorfer from Dynatrace and Marko Bevc from the Scale Factory. So we've got two really interesting talks coming up. Unfortunately, as we've already noted in the comments section on YouTube, no pasties. I'm afraid it really doesn't. Remote pasties is not a thing yet.
Well,
maybe
cars do deliver, so you can order from cars and they will deliver.
So
it shut down for a while as part of the coronavirus outbreak, but I believe they have reopened again and will deliver.
Right, so it's a bring your own pasty kind of thing at the minute.
Yep.
So guys, thanks very much for joining us. How is whereabouts are you both based? Where are you based, Jürgen?
I'm based in Linz, Austria.
Right, fantastic. Well, that's a truly international speaker lineup. And Marko, whereabouts are you?
I'm actually a bit closer, so Lancaster.
Lancaster, right? Oh, that's just down the road from me. I'm in Kendal in the Lake District. So,
oh, really? Oh, cool.
Within stone throwing distance.
Yeah.
So this is Cloud Native and Kubernetes Manchester, and none of us are actually in Manchester, which is great.
No, not even in the same county. Well, these things are becoming much more, much less localized now, though, Nick. It's the new thing, the new world.
So I hear.
So, how is lockdown? Are you still on lockdown in Austria, Jürgen?
No, not really anymore. So it opened up, I think, like maybe 10 days ago, I think it was, and now it's becoming more and more relaxed. So beginning of June 15th, we are opening up the borders to a lot of other countries where we have direct borders, and also traveling will be less restricted. So it's getting better. But yeah, I'm living on the a little bit on the outside of Linz, so I have a forest and the woods very nearby, so it's fine. Taking a walk, enjoying the nature, you know.
Yeah, I mean that's been the one of the saving graces for living in the Lake District as well. Really is. And you know, we live in a little village, and it's very easy to get out into the countryside. I guess that's the same for you, Marko, right? Lancaster's pretty close to lots of open air spaces, and
yeah, it's about the same area as you live, so it's very close either to go to Lake District or even by Yorkshire Dales. That's quite close. So
fantastic. So have either of you done many of these virtual events over the last few months?
No, first virtual event, I think it is for me. It was, I think in the beginning, a couple of them, they paused, and now it's coming up again. But first virtual event, I'm really looking forward.
Great. Yeah, I've done far too many of them. They seem to be cropping up about every 2 weeks at the minute. I would have been spending most of my work life on the road going to conferences, and it's I was expecting it to quieten down in this coronavirus epidemic, and it hasn't at all. In fact, because it's easier for people to put on virtual conferences, it's been insane. I think I've got five virtual events this week, including one at 7:30 a.m. tomorrow morning. So it's also people get to ignore time zones.
It's brutal.
So for those of us in the developer advocacy world, it's actually a ton more effort than previously. Nick, what have you been up to?
Nothing all that exciting, if I'm honest. Yeah, just keep it on, pretty much.
Ranchering, you've got your new job.
Yeah, new job. That's it. So getting up to speed with a lot of ranchers' new stuff. We were so long haul went GA last week. Last week. All the days and the weeks are blurring into one at the minute. So I've not yet had a chance to play around with it, but there's been quite a lot of press regarding that. But otherwise, yeah, it's just me getting up to speed with some of Rancher's offerings.
This is the new storage.
Yeah, new block storage, cloud native block storage. So I think it's been CNCF sandbox for quite a while. So it's handed over to the community a while back. But it's hit 1.0, so it's now production ready, GA, whatever that means.
Users now find the bugs. That's what that means.
Pretty much. Pretty much. Wasn't there a new release of DCOS? I saw 2.1.
There was the DCOS 2.1. Nice segue there for those DCOS users out there. Includes lots of funky stuff like vertical container bursting and lots of other goodness. You can find all about it at dcos.io.
You're much better briefed than I am on a respective company's latest offerings.
I've actually been spent the last few days writing CUDA operators for Kubernetes, Nick, which I'm sure you know the fun of doing, trying to work out Go and Sprig templating. So that's been a lot of fun.
Fun times. Sounds productive.
Right, so I guess we should kick things off. Who's up first? Marko's up first. So do you want to, Jürgen? I will drop you out for the minute, and then we will put you back in once we get to the break. So we'll speak to you a little bit later. And Marko, do you want to get your screen sharing on the go, and we will pass things over to you.
Yes, of course. I think it should be sharing now.
Yep, that looks great. Okay, well, I will leave you to intro the talk and intro yourself, and we will speak to you again once your talk's finished. Let me just with me and Nick.
Okay, thank you very much. So welcome everybody again from my side as well. My name is Marko Bevc. I work for a Scale Factory. We are a London-based consultancy. We are specialized in AWS workloads and mostly helping our clients get either onboarded or optimize their workloads in the cloud. So my today's talk is going to be about privileged containers and security issues around it. So before we properly dive in, let's just quickly have a look where I actually got the idea of this talk. So as many of you probably were there as well, it was FOSDEM 2020. So as you can say, it's still pre-Rona era where we can still travel around. And this was actually a picture taken from a Chris Nova talk called Kubernetes clusterfuck. So it was a very popular, interesting talk, which was focused around, specifically around container security as well. Whereas the remediation went in a little bit different way. They were presenting their own product Falco there, whereas I was more interested in seeing if we can remediate those issues by just mechanisms available to us in the pure Kubernetes world without any third-party tooling. So basically, what we're going to talk about today is it's about escaping boundaries. So usually, when people think about containers, of course, there wouldn't be a proper presentation of containers if there wouldn't be a picture of a real container there. So by boundaries, we usually think container as a isolated object that you usually have limited access to the underlying system, and by design you kind of expect you're going to be bound to those boundaries with specific either security mechanisms or mechanisms that they put there in by design. But if, as probably many of you are familiar, even if using Docker by default, the root inside the container runs as root on the host as well. So if you don't kind of remediate that, you can be exposed or vulnerable to different kind of boundaries, escaping boundaries, or even malicious exploits on your system. So just before moving forward, I have a short Docker demo to demonstrate this for a bit. So I'm just going to stop this for a bit, move to my terminal, which I was assured that it's big enough for people to see. So if I, for example, in my current running folder, run this command, which just runs a Docker container of using CentOS 7 image, I'm just going to execute bash shell, and I'm going to mount my current working directory in /source within the container. And what usually happens, we have a container running. As you can see, we are in the container. I can assure you this is not my operating system on my laptop. So we are in the CentOS 7 image running there. And as I mentioned before, we have the /source mounted in my current working directory. So if I change there, obviously, this is the same content that I will show after I exit the container. And what we can do there, we can touch random file there. Let's name it AAA because I'm lacking imagination at this point. So if we touch this file and we run it as root within the container, and if we exit that container right now, you're going to notice there is the same content, but the file here is actually owned and has root permission set on it. So as you can see, I cannot remove this file from my system since I'm a regular user. Sorry, I'm actually sudo there, so I was actually able to move it. But as you can see, my permissions were set to root, and if I would mount a different volume, for example, like sensitive volumes like /etc or other volumes, I would actually be able to modify my underlying file system, which probably isn't what we wanted there. So just quickly jumping back into my presentation there. So moving forward, this is just a basic kind of demo to kind of set us in the topics we're going to cover today. So first, I'm going to talk a little bit more about containers and their orchestration. Obviously, there are many orchestration systems out there. We're just going to uncover that a little bit, just kind of set the land before we move forward with some security mechanisms. I will mention a couple of those available to us if we are using Docker containers. We're going to look into some of those more into detail in orchestration platforms as Kubernetes. And then we're going to move forward with looking at some escalation methods that are available if we run containers in Kubernetes, and what are the exact remediations or actions that you can take to prevent those escalation methods in your production Kubernetes clusters. Afterwards, we're just going to quickly go through some assumptions for my demo environment that I'm going to do later on. And we're going to wrap it up with some conclusions and takeaways for securing your production workloads in the container environments. So as I mentioned before, if we just quickly have a look at this, which is probably the most kind of common diagram that people working with containers are already familiar with. So if we look at the containers architecture, what do we usually have there is we can split it up in a kernel level and a user end level, whereas on the kernel level, you would usually have some kernel drivers around it, and then namespaces and control groups, which are the basic objects that provide us the isolation we get with containers. And of course, there are some underlying, if you're using Linux system, security modules that are available to us to ensure additional security that we want to have there as well and enforced. So from the user line perspective, we would have containerized process running, which are ensured by the underlying Docker daemon or better say containerd, which is also responsible for ensuring that we have proper container images available before running those locally. And those would usually be pulled from some external registry, which can be either Docker Hub, or if you're running in AWS, it could be ECR repository or any other kind of container repository that's out there. And how do we interact with that? It's usually by using a local Docker client that would interact with the daemon. So if we move forward, as I mentioned before, there are different orchestration platforms out there. Today, we're going to talk about and focus on Kubernetes. And if we quickly have a look at how Kubernetes orchestration platform looks like from a really high perspective and from a, let's say, kind of architectural diagram, you would usually have a cluster controller manager and a cloud controller manager and the API plus scheduler, and of course the ECD value store that you use within the control plane. And on the other side, you would have different nodes which run usually kubelet and a proxy processes, which ensure that all the workloads have necessary resources available, for example, like networking, storage, and probably compute power as well. And underlying from there, there will be usually an operating system, or that can be either a virtual machine. That is probably most common use case nowadays, and an operating system running on it. So unless you're running Kubernetes in your own environment on bare metal, which probably is not the most common use case nowadays, you would run it most typically in the cloud provider. Either that is Azure, Google Cloud Services, or AWS. And the cloud controller manager within the control plane would ensure that specific resources that you ask for are made available for you. As I mentioned before, there are many different orchestration platforms. Kubernetes is probably the most commonly used one and most popular. You can even say that it's probably the only one that survived the hype cycle out there. So that's why we probably trying to put all our workloads there now. So moving forward, as I mentioned before, let's have a look at some of the security mechanisms. Firstly, let's start with the ones available for us if we're running Docker. So first of all, we have to be careful when running Docker and not run our containers as root. So as I demoed before, we definitely have to ensure we run rootless containers, which is proves to be a very bad practice and makes us quite vulnerable to different kind of exploits. There are definitely different kind of containerization options out there. For example, like Podman, which is running your containers rootless by default, but there are also mechanisms in Docker that you can ensure it to run it without root permissions. So another thing that's kind of it's good to keep in mind when running Docker is definitely drop all unnecessary privileges in container. That means limit the capabilities that you actually need and try to avoid specifically the administrative capabilities on your host system. The third thing I would like to mention here is also we need to be careful when mounting volumes and different kind of mount points outside of our container. As I showed in my first short demo, it can be quite dangerous to mount specific sensitive paths from the host system. So either you mount those read-only or you try to avoid mounting those and just ensure that your data is stored somewhere else, or you're using predefined volumes and ensure the data is there beforehand. If you're using Docker container, definitely you should think about setting proper daemon options and ensure that your endpoint is not exposed publicly. So that means by default, it actually runs on socket. So the recommendation there with Docker hardening is definitely check the socket permissions, who has permissions to access that socket. Or if you're running it using TCP, a very strong recommendation is there, use TLS to ensure encryption of your traffic. Otherwise, you might be exposed to different kind of external exploits, and it has been proven in the past that this is definitely not the best practice. The only thing I would like to mention here is also some kernel security features that you can use. For example, on Ubuntu systems, you can use AppArmor or SC Linux, which is most typically used on Red Hat flavored systems. And of course, seccomp, which is usually enabled by default, if I'm not mistaken. So moving on with security mechanisms available on Kubernetes systems. So almost similar things apply here. So for example, definitely secure your endpoints and worker nodes. This means that specifically if you're running your own clusters, ensure that your control plane is not publicly exposed and only available to secure clients, for example, like internal users or maybe CI/CD systems that need to access those. Definitely enable role-based access controls, which gives you a really nice way of setting proper permissions to a very granular level on a cluster, on your run cluster. One of very good practices there is try to minimize your entry point footprint. So this means that definitely apply your manifest through the CI/CD pipelines rather than directly, and of course ensure that you're scanning manifest and containers before applying containers images before running and applying those on your Kubernetes clusters. And of course, we definitely shouldn't forget about network and pod security policies, which we'll talk a little bit more in detail a little bit later on a couple of next slides. So moving on to the escalation methods that we will look into. So the first one, which you might say it is a bit boring one, but it proves to be quite effective on most of clusters, is so-called mounting Kubernetes secrets. So this means that even if user is authorized to create resources in a specific namespace, this doesn't necessarily prevent them to mount secrets that are mounted on the host itself. So we're gonna have a look of example user RBAC manifest in next slide, but just kind of to go through what the escalation method looks like. Even the user is limited by what they can access. They can still access the varlib, kubelet pods, and Kubernetes secrets folders underneath that path. So the command with which you can achieve that is showed here. So by simply running kubectl and use, for example, like busybox image, you can simply mount that by just using a simple override JSON file, which I will also show in the next slide. So escalation from here really depends what you're running on the node. So it doesn't necessarily mean that you can escalate much further than that. And by default, nothing, specifically if you're running on AWS, which I will be demoing everything in today. By default, nothing there indicates that you can escalate the privilege any further by using that method. But another perspective there could be, for example, to gain access to secrets on all nodes. You can easily use a daemon set and just grab secrets from every node by using the same method here. So instead of running a pod, you can just set a daemon set and run the same thing. So just if we quickly look at the manifest for the RBAC configuration for that user, as I mentioned before, the user is limited to their namespace. We have preset a row that only allows them access resources created in the namespace. Of course, we are binding that role to a specific user. And in this case, since we are on the AWS, we are using user mapping to a specific IAM user that's lying underneath there. So nothing really special there. As I mentioned, user limited to their namespace and just accessing resources there. And as I mentioned before, let's quickly have a look at the overrides JSON file there. So as I mentioned before, with a couple of overrides, we can easily mount that. And how we achieve that is by just using basic volume mounts. And for example, use kubelet volume and set mount path to /var/lib/kubelet and attach that volume to a container. And voila, you have the secrets mounted in the container and accessible to us without any restrictions, even though originally we were restricted by RBAC to our own namespace. So with that, let's look at our second escalation method, which I will demo later, and we will have a more in-detail look. So this one is a little more dangerous, and let's take it to our next level. So user is the same, just limited to create pods and other resources in a specific namespace, and of course it has cluster access via a kubectl. And by just running a pod with the common modern Linux distribution as a container image, by using a couple of overrides there, we can actually escape the container. So a couple of spoiler alerts before a demo. Yes, we can elevate all our way up to the root on the node. That means we can check the EC2 instance user data, which can reveal how the node was bootstrapped or where the configuration for kubelet lives. We can expect running containers on that node. Furthermore, we can even grab private key material and get kubelet's kubeconfig, which we can actually then use on our client side as authentication method to gain full cluster access, which is definitely not what was original intent with RBAC. So just let's quickly have a look there what we're going to run later in the demo. So I have a simple function in Bash, nothing too fancy. What we're going to use there is ncenter, which for people that are not familiar with that command is just a command to execute a new command running in the namespace of an existing process. So in this case, we're going to run bash in the namespace of our process, sysin process, which is with pid1. This means it's going to be run as root. And we're going to demonstrate that we are actually on EC2 instance node by grabbing user data from that instance. And we will gain the certificate material and kube configuration that will enable us to get complete cluster access there. The rest of the overrides, I mean, the important part there is actually what we're going to do. We're going to also be overriding our security context, which we're going to use and set privilege to true. This means that our container image will run as privileged container on the host, and that will help us actually elevate our privileges to root on the host itself. So just before diving into the demo, I would just like to go through how we can resolve and prevent those kind of events, which we'll also do in the demo as well later on. So first of all, I would definitely recommend using pod security policies or any other kind of methods. As I mentioned before, there are plenty of projects out there that that you can use to achieve the same thing. As I said at the beginning, my intention there was to use the mechanisms available within the Kubernetes itself, rather than using any third-party tooling, which is probably as good as any. but sometimes you have specific requirements not to use anything external. So that's why I was interested in using pod security policy there. So if we apply our pod security policy that I will show later on, pods validated against that are actually, we're going to prevent them, and they are unable to use host path and mounting, which will prevent us of mounting secrets, and we will prevent running our containers in privileged mode, which will prevent us of actually gaining root on host, or probably kind of trying to prevent any other kind of possible escalations there might be. There is also a couple some further hardening locking that you can do. For example, you can use read-only file systems when running your containers. Of course, you should definitely not be running your workloads within the containers as well. And also, you should avoid, as I mentioned before, using Docker as such. Drop all unnecessary capabilities, or prevent, people applying manifests of elevating those from the defaults. How do we actually use that pod security policy, right? So we need to create a cluster row and a cluster row building if we're going to apply that on a cluster level, which in this case we're going to do in the demo. And we need to assign that a specific user or group that can actually use this pod security policy. So just to maybe kind of elaborate there a little bit more. So how pod security policies actually work is that when user, or let's say secure service account trying to execute something on the cluster goes through all security policies and applies the first one that matches that user. So it's a bit different that one might expect. So it's matched against the first appropriate candidate rather than a specific bin to a specific user or group. So by just using those pod security policies, we will show that you are able to prevent any kind of other exposures or previously showed escalations, and we're gonna protect our cluster by using those pod security policies in the future. So as I mentioned before, we're going to use AWS EKS, and by default, if you're using that, you're probably familiar that default pod security policy that is deployed, I think, since 1.13 or 1.14. Is called EKS.privilege, which is exactly what it says on the tin. So it allows everybody or everyone on that cluster to run everything. So in this demo, for the sake of simplicity, we're just going to amend that, and just kind of cautionary note there. If you are doing that, it's probably not very good practice. And definitely you should be careful if you're amending the default policy, as you might break your cluster and you might need to redeploy a new one, since you will probably lock yourself out if not careful enough there. So as I mentioned before, let's just quickly have a look of our pod security policy we're going to use. As I said before, we're gonna disable running privileged pods. We're also gonna disable privileged escalation. Also, we're gonna disable mounting volumes and a couple of other things. For example, we're gonna disable using host networking, IPC, and host bit, as all those capabilities are not necessarily needed for most of the workloads. There are a couple of annotations there as well. We're just going to use default runtime profile names, which is good enough for our demo today. As I mentioned before, in order to use that pod security policy, you would need to create, in our case, it doesn't have to be cluster row, but in our case, we're just going to use cluster row. which is using specified rules to use the pod security policies. And we're going to use cluster role binding. And as I mentioned, for the sake of simplicity there, we're just going to override one of the groups already defined. So in our case, it's going to be all authenticated users there. I'm also going to show a caveat there that you need to be careful if you're taking that approach, which it's definitely not suggested for production workloads, but it just shows us how we can achieve that. So just before kicking off the demo, a couple of points there to just set up the context. As I mentioned before, we are going to run this on the currently latest AWS EKS cluster 116. It's going to be completely patched. We're going to use managed node groups. You can as well try this on unmanaged workgroups. The intent here was just trying to show that even if you're using a partly managed cluster from your cloud provider, there might still be some bits that you need to take care of, and you need to be careful about the responsibility delegation that's usually in place in cloud environments. So worker nodes are going to be only available in private subnets, and we will have cluster-wide enabled RBAC. So we will have limited user access there, which will be limited and constrained just to the user namespace that will be set by using RBAC. Okay, I think that sets it quite well. Now let's go and try to escalate our privileges to gain more control that we were originally intended for. So time for demo. I'm just going to switch back to my terminal there. So as I said before, we are running an EKS cluster, which is 116. I deployed 3 nodes, which we can see here are just default name nodes from AWS. I am running default pods that come with clusters, so just default pods deployed in kube system namespace. So as usual, just the CNI nodes, core DNS, and a proxy. And as I mentioned before, I have 2 functions defined. The first one is called shell u as shell unrestricted. In this case, I'm just going to use the default user. And in the second case, a function is called shell. And in this case, we are actually going to impersonate a user that I'm going to create, which will be using a newly created pod security policy that should prevent that user of escalating privileges further. So the user will be called fake user. It's just going to run CentOS 8 image, and we're going to run shell in it. As I mentioned before, we're going to use a couple of overrides. The important bit here is we're going to try to override the security context and use privilege pods there. Just going to exit it out. So as I said before, just going to quickly show you. I'm going to create a fake user, which is just a service account I'm going to use for this demonstration. And this fake user is going to have a role binding to a specific cluster role, which is edit. So let's just go and quickly create a fake user. So the user is created. We're going to create a fake editor as well. So as we have this set up, I'm still not going to enforce pod security policy, just to demonstrate that if I run my shell, it's going to run the container. And as I said before, I'm actually rooting that container, right? So if I, for example, say what OS I'm running on, of course, it is CentOS 8. I'm running there. You can see the file system here as well. And as I mentioned before, we're going to use Center, and we're going to run bash in a different namespace, so in a root namespace. And what that will actually achieve is, boom, we are immediately on our host, which is one of the nodes that we're running on, and we are root there, right? So just to show you there, it's Amazon Linux version 2, and we are actually on the host there. If you look at the file system, you can see it's different file system. As I mentioned before, what we can do there, we can look at the images running there, container images. So we can see there is actually our scary shell that we're running. There are a couple of other containers, of course, kubeproxy and some post containers. And we can even do some more interesting stuff as well, right? So let's try to get some user data here. So I'm just gonna curl that, and we can see that our cluster was actually bootstrapped using that script. Okay, we say fine. Let's try and see how it was bootstrapped, and we can actually see exactly how the AWS is bootstrapping that node, which in this case might not be as interesting since they are using different privileges there. So what we can also do, we can check Kubernetes configuration, check the kubelet there. We can see that kubelet is running with default configuration there. We can see and grabbed our client CA file. And we can also do this, for example, which is probably the most interesting bit. So we can go into the default path, which is var lib kubelet. And what we can do there is we can find kubeconfig. And boom, we have our kubeconfig there, which we can actually use and elevate our permissions out of the RBAC limited permissions that we were assigned to. So complete access and complete control of the cluster, even though originally we were just meant to control resources in our own namespace there. So just and because we are good people there, we're just gonna try to remediate that now. So what we're gonna do, as I mentioned in my presentation, we're gonna override. Oh, sorry. First, we're gonna apply our pod security policy there. So what I'm gonna do, just gonna apply pod security policy, and I'm gonna use some RBAC on it. So just quickly show you how it looks like. Like I said before, we're denying the privileged escalation there and mounts. And if we quickly have a look at the RBAC here, as I mentioned before, the important bit here is pay attention what we are doing here. So we are actually binding it to system authenticated users. So this will apply to all the authenticated users. And we're gonna override that role as well here. So we're gonna override the cluster role, which is the default role for authenticated users. And we're gonna replace the pod security policy from EKS privilege to EKS limited that we created now. So let's just do that as well. So EKS, applying that. And if we check our pod security policies, you will notice that I've added the EKS limited, and this is now applied to all of our default authenticated users. So if I try to execute my shell, boom, immediately I get rejected by the Kubernetes itself, and specifically by pod security policy, saying that we were denied by trying to use security context, host bit, invalid value, not allowed, and specifically we were violating the security context privilege. So privileged storage containers are actually not allowed in the host. And as I mentioned before, if we don't use that user and just try to use the default user, we are still going to be denied here. And the question is, will that cause us any problems? And the answer is actually yes. Because if you quickly look at the daemon set there, you're going to notice that running your CNI containers actually requires them to be privileged. So just for the sake of the demo, as I mentioned, you should always use service accounts and limit those specifically. But since we overrided the default policy, we want to enable our CNI to be provisioned and use privilege mode. What we can do here is we can actually override the cluster role for AWS node. And with that, we set it to use the privilege. And with that, we actually bypass the limitation of having CNI not being able to spin up and provision properly. OK, so back to my presentation and my last slide there. So a couple of conclusions. Container orchestration platforms are nice. They usually come with batteries included. That means that they are by default quite secure, but we still need to take care of the security from the platform perspective that is kind of delegated towards us in a cloud delegation responsibility model. So I said, out of the box, it's usually remote exploit safe. But we should be careful even if we open up to internal users, there might be some additional security mechanisms that we need to be aware of and use, and not just expect it's going to be completely safe. So as I mentioned before, definitely cover all your basics, protect your crown jewels. That means control plane worker nodes. Try to avoid using rootless containers, so least privileged pods. Definitely change defaults. You might be careful because pods by default also have access to EC2 credential access, which is usually not desired. Definitely apply your manifest through and apply your manifest through your pipelines and enforce that kind of a workflow rather than enabling kubectl write access for users. And of course, as usual, limit your blast radius by using namespaces and isolate workload access using those. And same goes for definitely scan for vulnerabilities in your images and check for updates for regularly on your system. And as promised, takeaways: Kubernetes RBAC is complex, probably not enough on its own, as we proved through our demo. And to answer our question from our today's talk title, everybody should be afraid of privileged pods. So with that, I'm sure I can make this available after the talk. So I'm just going to leave it with a couple of resources for further reading. And with that, I'm wrapping up my presentation. And please keep in touch. I'm happy to answer if there are any questions.
Nice one. Thanks, Marko.
Cool. Thank you.
I don't think we've had any questions in yet that are specific to your talk. There was a general question in there from 101 blog asking about the best way to get started with some of these technologies. I think he means in general. Maybe we can save that answer for the end and we have a general chat about getting started with a few of these things.
Sure. Sounds good.
Cool. Well, once Jürgen reappears, we can get moving along with the second talk of the evening then. Out of curiosity, Marko, have you had a chance to play around with any alternative container runtimes that provide extra safeguards as far as security is concerned? So things that basically wrap up containers in some other form of virtualization. I'm thinking about things like Kata containers or There's a runtime for Firecracker, that sort of thing. Have you got a chance to play around with any of those?
Yes, definitely. I mean, for example, if we would use Fargate on AWS, we would kind of limit the blast radius as well, since underneath they're running Firecracker and they are limiting the capabilities they can use there. So, for example, by default, there are some limitations, such as you cannot run privileged containers if using Fargate on EKS. So this would definitely limit that. And there are some technologies out there, as I mentioned, that are not part of the Kubernetes as such. For example, the one that's really getting a lot of traction now is Falco, which is a container that you run within your Kubernetes cluster and kind of rejigs within the kernel using eBPFs and trying to scan all vulnerabilities through the kernel and kind of tries to block you on that level and prevents any other possible escalations from that area.
Cool. So Dave says that, Kata helps a bit, but if your Kata is allowing you to share a mounted host file system, then it's going to let you. Oh, it's going to let you. I thought that was like ... It's going to let me what?
Very true, very true.
Cool, yeah, and I think you've scared a few people as well. So everyone's probably off to read more about pod security policies.
We should stop mentioning takeaways at the end of these talks on these virtual meetups, though. They just end up making everyone hungry.
Yeah, maybe I should save those for when we can return back to Manchester, though.
Absolutely. We've got another question, actually, Marko. What tools do you suggest to check your security? Bias towards, I guess, what security tools are there out there? I think for the container world is I'm interpreting that question as. Yeah, like I mentioned, there are plenty of out there. For example, Snyk is having a lot of good container scanner tooling available out there. So those are definitely the ones that I would recommend using. And there was the one that, what was the one that Acquia open sourced recently? What's that called?
This Cube Hunter, and there's another one, isn't there?
Yeah, I can't remember what that's called.
Cannot remember the name right now. Yeah, there's definitely that one as well.
Yeah, Cube Hunter I've had a play around with. It's quite nice because you can just run it. There's like an ad hoc mode where you can just run it against your cluster, but then you can run it in your cluster as well to do periodic scanning.
Yeah.
Trivy was the that's the one for image vulnerabilities.
Yeah, definitely. And as I mentioned, Falco is the one that you run within the cluster, and it scans the system calls on the kernel level, so it prevents any kind of activity from your containers on the system. So it's not probably targeted specifically for containers. I mean, it also scans the activity within that container, but in general, it's trying to secure the whole environment rather than just containers. Yeah,
I think we were saying in the chat that both our other organizer Danny and myself were both in that Chris Nova talk of FOSDEM. I think we were actually in your photo, so that was quite nice.
Okay, yeah. It might be as well. I mean, I have to say I really enjoyed that talk. It was very entertaining and useful.
Yeah.
Somewhat jealous as I've never actually managed to get to FOSDEM. And I'm not sure I ever will be able to do so.
Oh, there is still hope for next year.
Yeah, I suppose we'll have to just see how things go.
Chips and mayonnaise, that's what it's all about over there, Nick. I'm not sure you like
pasties. Au contraire, I love chips and mayonnaise. Right, this is just making me more and more hungry. So let's move on with the next talk. So I can go get some food.
I'll drop Marko out. Shall I? Thank you, Marko.
Thanks again, Marko. That was awesome.
And say goodbye.
Cool. Right then, Jürgen, over to yourself. I'll let you do the appropriate introductions and stuff, and we'll jump back in at the end for any to answer any questions and to close out the night.
Cool. Thank you. Can you already see my screen sharing? So I assume everything's working. So I just start off here. Yeah, thanks for giving me the chance to present at your meetup. Really enjoyed it so far. A great talk, Marko. Today I want to talk about overcoming scalability issues in your Prometheus ecosystem. It's basically based on a blog I've written recently, and it's some of our learnings, some of our findings we saw when dealing with Prometheus and scaling up Prometheus with onboarding more and more microservices, building all this Grafana dashboards around it. This is what I want to share. It's in the context of an open source project I'm heavily contributing to. That's called Captain, and I would say like in the last third of the presentation, I will touch the Captain project and show you how we are kind of trying to overcome these issues and how we are probably help you if you want to overcome these issues as well. I work for a company called Dynatrace, but that's an we call it software intelligence vendor, originally from the APM space. I would say like I'm very familiar with application performance monitoring, as also Prometheus does. But I also have an ask for you to, if you have some feedback, if you have some insights into your Prometheus environments, your Grafana environments, just let me know. Put the questions in the chat, and I guess Matt and Nick, they will let me know at the end of the talk which questions you have posted, and we can probably have a discussion. Also, you can reach out to me on Twitter, LinkedIn, or like other options. I will also share the slides afterwards. You have this clickable here. But now let's dive into this. So what we actually want in our cloud native and Kubernetes environments is basically we want dashboards, we want all this monitoring, observability, we want alerts if something breaks, and we want to have it with the least configuration that's needed or that's possible. Or we are writing a lot of YAML these days, and we are writing a lot of configurations, and then writing more and more configurations to basically configure our Prometheus and to set up our alerting, and then set up our dashboards on top of it, and then configure dashboards and make them available for more and more applications, and define which metrics we actually want. That's a lot of work. And what we found out, there are a couple of kind of standards like red metrics or use metrics or whatever you want to have that could be or should be actually provided out of the box whenever you are moving workloads to your Kubernetes clusters. So we were thinking about how can we actually automate those parts. So for this, I want to talk with what do we have, what are basic building blocks in our Kubernetes environments, and then I will go through those challenges that we saw with users of Captain, but also with folks that migrated either from Prometheus to Dynatrace, or they were just also using both systems in their production environment. So I would just want to highlight a couple of challenges. I will also propose some solutions for each of those challenges, and then, as I said at the very end, I want to show how we are actually in Captain, we are trying to overcome these challenges. So at the very beginning, we have like our application cluster, we have our pods, we have our workloads running, each of them exposing probably an endpoint where Prometheus can fetch the metrics. And we have our Prometheus cluster running with our Prometheus backend and Grafana as the dashboarding. What we also have most often, and I'm not sure if you can see my mouse as well, but in the upper part, we don't only have one application cluster, but we have maybe a couple of them. Most often we have a couple of them. And for the Prometheus cluster, they might be the same. So we might have more than one cluster, and scaling those clusters, like provisioning more hardware and these kind of things, that's not part of this talk. There are already a couple of solutions out there. What I really want to talk about is how to scale this Prometheus ecosystem, how to scale all those alerting, scrape, charts, dashboards, all these kind of things where you usually write configuration, how to scale these kind of things. It's not about the scaling of provisioning more hardware and installing more Prometheus clusters. But nevertheless, having Prometheus, having Grafana, everything really needs configuration. As I said in the beginning, it's a lot of YAML or JSON to write. Yeah, this is actually a challenge for all of us, I guess. So first challenge is you have a team, or it's maybe just one ops or DevOps engineer, and you're writing all those scrape jobs for Prometheus, alerting rules for the Prometheus Alert Manager, all those dashboard configs for Grafana. You're writing those. Sometimes you're just applying it in your, like with kubectl, what we just heard might be dangerous, probably. So you're just applying this in your production environments, which might be quite tricky. So there is really no centralized way how to manage this configuration. And one solution is basically put in everything into a Git repository and then have an operator applying this to your different components, like the Prometheus, like the Alert Manager, like Grafana. So put everything first in the Git repository and then not applying this directly, but in a GitOps way, the operator would take a look at the master branch, for example, in the Git repository. Everything that's merged will be applied to your Kubernetes environment, meaning to your Prometheus and the other parts. This can be done with, there are a couple of operators out there. I think Flux is one of those operators, which is quite well known. So you can basically use them to achieve a little bit of more, to have this a little bit more loosely coupled and not applying those edits to your production environments directly. Still, there is the problem with who writes all these configurations. It's some of those are different languages. So scrape jobs, alerting rules, both is YAML for dashboards. In Grafana, you might use JSON or some other or JSONnet or Graphonet, or you might use some libraries. But still, it's a lot of different files you might have, and you end up with. So it's a lot of different configurations because you don't only have one application, but you have like really a lot of microservices, and each of those needs maybe a little bit of different configuration. So what you can use is some kind of code generator. You put in between, basically you feed the code generator with what you really want to achieve. I've not referenced some code generators here. I have a reference section at the end. There are a couple of those out there. If you know more, other than the ones I listed, I'm really happy to extend this list. And those are doing a great job. So you can really feed those code generators, then you generate the actual configuration, you put this configuration into your Git repository, the operator then applies it to your Kubernetes cluster. That's really a cool thing. But then one other problem occurs that we've seen. It's basically that over time, these different kind of configurations, they might run out of sync. They drift apart, basically. So for example, you might introduce new scrape jobs, but in your dashboards, or you rename some jobs, but in your dashboards, you still have to change this. So it's basically, there is no single configuration that holds everything, but you have different parts, you might have different files, and you have to make sure all those different files are really in sync. And one way to do is to put some abstraction in front of this. We call it some SRE concept-based abstraction, SRE, site reliability engineering-based abstraction, where you really focus on the concept of site reliability engineering, because all those observability topics and monitoring really, I would say, comes from, or is very dominant in the SRE community, since they define their service level objectives and these kind of things based on monitoring data, based on data you can fetch, and where you can basically evaluate the quality of a microservice. So you can put this in front, and with this, you can really define what you want and the how it is done, how the configuration has to look like can be generated. So you can really focus on the what, and you can basically generate the whole rest of it where it is like how you want to do it. And of course, you can regenerate it, you can just version it, all these kind of things, then kind of just come, let's say they come for free, not really, you might have to do some small adaptations. But the important part is you want to define what you want instead of doing the hard work of writing all these configuration files manually. So this is what we saw that that might help a lot of our users of Captain. But Captain is a little bit more, and I want to show you what is Captain actually, and how you can automate the configuration of Prometheus in Grafana, how you can scale it up for a lot of different, lots of microservices, the whole workload you're managing in your Kubernetes environments, and then also how Captain actually triggers automated quality gates based on the same configuration files, and even more, also do automated operations with auto remediation that is automatically executed. So with this, I give you like the one sentence explanation or description of Captain, and we say it's an event-based control plane for continuous delivery and automated operations. I would say it's a lot of buzzwords in it, but I will try to break it down. Let's start with the first one, event-based. So it's basically, Captain is a control plane, so it's living in your Kubernetes cluster, and it's receiving and sending events to other components, like a service for Grafana to configure Grafana, like receiving events from testing tools to know now when I receive an event that a test has finished, I can start to evaluate the tests. So it basically lives in the cluster, and it's able to receive events and then trigger the next part in its workflow. So with this, Captain can do continuous delivery. It's basically you tell Captain that you want to deploy something. Captain will start the deployment. Once the deployment is done, Captain will trigger a testing tool. Once the testing tool is done, Captain will trigger the evaluation of the tests. Once this is done, Captain can promote it to the next stage. This is more or less how it works in a nutshell. And the same for automated operations. Once you send some alert to Captain, Captain can then trigger a remediation action based on the content of this alert. So you can integrate Captain into your Prometheus alert manager, and Captain will try to remediate the issue by, let's say, scaling up the replica set, or rolling back the deployment, these kind of things. So how does Captain work, and how does all these basically services I was mentioning, how they come into play? So in Captain, again, a lot of things are based on configuration, so there is no need for you to write any of those like procedural code. It's based on configuration. The first configuration is a shipyard file that basically defines how many stages you want to have in your Captain environment. And with the stage, we really mean like, let's call it a pre-production and a production stage, and which tests you want to execute in these kind of stages, and if there's any auto remediation you want to execute in these stages. So it's really a very simple YAML files. Most of the files that we see, they are around like 20 lines of YAML, because they only describe this, the stages, and the most folks we work with, they don't have more than, let's say, like 3 to 5 stages, like maybe a development stage, hardening, pre-production, production, something like this. And to this control plane, you can then add, you can simply add the services. It's a pub/sub mechanism, so you basically subscribe for topics, and then you can add the different services. For example, GitOps. Everything in Captain is stored in its own Git repository. You can link it to GitHub or Bitbucket or GitLab. So all the configuration of Captain is version controlled, and it's basically applied in the GitOps way in its Git repository, living in the cluster, but might also be synced to an external Git repository. Captain can then be synced and linked also to a container registry like Docker Hub or others. Can be linked to continuous delivery tools, or we can just use the built-in mechanisms of Captain. Can be linked to test automation tools, to chat up tools, but also, and here comes now the part that's interesting for Prometheus and Grafana, can also be linked to Prometheus and Grafana. So each time there is a new microservice, for example, dashboards can automatically be generated. Each time there is a new event sent to Captain, all these kind of services, they can subscribe to this event, they can listen for this event, and they can react on this event. So let's say if there is an event to start the tests, probably a JMeter test or a Selenium test or these kind of services, they would react on this, and then they would execute it, and just once they're finished, they would just tell Captain the tests are finished. And other services, probably let's say a Slack service that wants to send out a notification to the developer that tests are now finished, would react on these kind of events. And Captain, of course, has some built-in services that control the workflow so that you can deploy the services with Captain by also satisfying or basically checking the quality of a service based on those SRE files that I will show you just in a minute. So this is basically the Captain platform, let's say, where you can just plug in different tools, and we will focus on the Prometheus and Grafana integration. Before this, I have to show you a little bit how Captain works when a user really wants to start with Captain. In Captain, everything is managed in a project. In this case, we are just simply creating this project based on the shipyard file, and I pasted here a very simple shipyard file with just the first stage called stage and the second stage called prod for production. So based on this, Captain will basically create its own Git repository and create different branches for those for this project, so that you can version all the artifacts and all the configuration in these two branches. So you have the distinction between everything that's going into stage and everything that's going into prod. So actually, in the screenshot, I called it staging. So this should be staging here as well. Next part is basically you onboard a service. And onboarding a service is just you add the service to a Captain project, and you onboard it with a Helm chart. So we are using Helm to have all the deployment manifests we basically need, or the whole package we need. We give it to Captain, and Captain can then manage this. So we are just telling Captain here, this is here we called it a simple node service with the Helm chart. And in the next part, we can configure our monitoring tool, which is Prometheus, based on the shipyard file, because we know which stages we have, and also based on the Helm chart, because we already know a couple of things of the like the service name and these kind of things. We can use this for the configuration of Prometheus and Grafana. So we can automatically create these kind of scrape jobs. We can create the alerting rules. For the alerting rules, of course, there's some information missing, because we also need like when to alert. I will show you in a minute how we are doing this. And we can also create all these dashboards because we already have a lot of information. So it's basically just one command to configure the Prometheus monitoring and Grafana by just subscribing to this event. So each time there is a CLI command sent, the event is sent to the Captain control plane, and the Captain control plane distributes the event to each service that is listening for this. And yeah, when we want to deploy a new version of our artifact, that's basically the same. We are sending the new event about a new artifact to the Captain control plane. In this case, I just omitted here the service of the project, but it's important is we just deploy a specific version of the card's microservice. So Captain will go ahead and rewrite the Helm chart. Captain will go ahead and if it's a blue-green deployment that we defined, Captain will basically do the blue-green deployment for us in our staging environment. It will start the tests. It will then reach out to the monitoring tool to gather the test data, to gather the performance data during the test period, and then to score the tests based on an SLI and SLO file, which I'm going to show in a minute. And then Captain will decide if this artifact can be promoted or if it has to be rolled back. If the let's say the quality is satisfying, it will be promoted to the next stage. In this case, it's production, and we do the same workflow basically again. So the beauty here is that you can replicate the same workflow for all stages you might have. So if you want to add a new stage, like let's say a security checking stage that we just heard in the previous talk, you can easily add this, and then the test might not be a performance test, but you might add a security testing tool that does a container scan. So there might be a specific stage or a specific stage for it, where you can basically do your performance tests, and you can also generate the score, and based on the score, you can promote it to the next stage or not. So in this case, let's assume the microservice is doing fine in production, so we can keep it there. So how are we going to do all this configuration of the Grafana dashboards and the Prometheus alerting rules and these kind of things? And we are basing here on some SRE, I call it SRE best practices. They are coming from the Site Reliability Engineering book. That's one of the, it's a kind of a famous book in the SRE community. I've also linked here a YouTube video where you can check it out. The SRE book is by the way, is for free if you read it online, or you can just order it also online. And the important part is here that they are distinguishing between SLIs, SLOs, and SLAs. We in Captain, we take the first two parts very seriously because that's the parts which can very easily describe the quality of a microservice. So a service level indicator is basically a metric that you can measure, and this will be something we can query from Prometheus, for example. So the example I put in here is the error rate of one specific service, of the login requests of one service, for example. So this is just a metric. It just says that's the error rate. And the service level objective is then something, an objective based on the service level indicator. Something like the login error rate must be less than 2% in a given time frame. And the service level agreement is something, it's basically a business agreement between a consumer and a provider, and these are based on SLOs. They can combine also different SLOs. And the example here could be, it has to be the logins must be up and running 99% of the time within a 30-day window. So you can really distinguish between the SLIs and SLOs, and you can use SLIs within your SLOs, and then you can use the SLOs within the SLAs. So for SLIs and SLOs, I will show you a very small example. And for the SLIs, you can think of like the RED metrics or use metrics. There are different methods out there, but they are very well known, and I would say like they are widely accepted to also be used in dashboards. So Captain already includes this kind of RED metrics and automatically generates these metrics and dashboards for these metrics whenever you onboard and onboard new services and configure the monitoring for these new services with basically the two CLI calls I showed you. So it's basically just Captain onboard a service and then Captain configure the monitoring. So for an SLI and an SLO, you can think of this, the SLI is just, the SLI file in Captain is just a series of different queries. Here in this case, I just took some Dynatrace queries, but it's basically just the PromQL, or in this case, a Dynatrace query, how to fetch the actual metric, and then you could just assign it a name. So in this case, we just assign the name, the error rate, or the number or the count of database calls, or other things. And then in the SLO file, you can just reuse them. And you can base your objective on different SLIs. So in this case, I'm basing my objective on the error rate and also on the count, and also counting the database calls. And the error rate has to be smaller than 1, which basically means has to be smaller than 1% for it to pass this criteria. And for the database calls, they are allowed to basically, there is an increase allowed of +2% between this run and the previous run. And you can write objectives files very easily by just using this static thresholds or relative thresholds to compare to previous runs, for example. Then you can assign it a total score that you want to achieve. Just move my mouse somewhere where I cannot see it anymore. So you can assign it a total score. And in this case, Captain will then evaluate the total score. Each of those SLIs will get 1 point. And depending on the overall outcome, if you match the criteria or not match the criteria, it will sum up the total points and then give you back a score. So in a very simple example, you can start again the evaluation with a very basic CLI call. And Captain will then reach out to the data providers. So let's assume reaching out to Prometheus, asking Prometheus for all the service level indicators that are used in the service level objective file. And those service level indicators are not only used in this objective file, but also used to generate all those dashboards. So when we come back to the slide that I've shown you, where we saw the different services that you can attach to Captain, then you can just attach the Prometheus service and the Grafana service, and it's basically Captain can then write to those instances and also fetch data from those. So in this case, it will fetch from Prometheus some data about the memory footprint, for example. It will evaluate the score. So if it's a full pass, it will give you 1 point. If it's a warning or like a half pass, it will give you 0.5 points. And based on the total score, it will then decide if the quality of the service is satisfying or not. And also based on the SLOs, like in this case, SLOs for warning or a pass, it can also create, and it will create directly alerting rules for your production environments. So if the error rate is higher than the objective, it first of all should not really pass the quality gate. But if it passes the quality gate, but later on, due to maybe your tests are lacking the quality, or like there is some unexpected user interaction on your website where you just don't have tests for, you can still use those kind of files for where Captain automatically generated the alerting rules for you. So you will get alerted if something in your service level objective file is not satisfied. So the integration of Prometheus into Captain and also Grafana, it's basically living in our Captain contribution repository. So we have our Captain core control plane and all the other services where we integrate with external tools we have in our Captain contribution repository. We have a couple of services living there. We have services talking to Slack, services talking to Neoload, which is a performance testing tool. We have services talking to Jira. But yeah, as said, we also have these services talking to Prometheus and also talking to Grafana. The Prometheus service itself is basically configuring Prometheus for monitoring of the services and also creating the alerts and also receiving alerts from the alert manager and translating them into cloud events that are used by Captain. And the Prometheus SLI service, on the other hand, is responsible for fetching all those metrics from Prometheus and also creating the metrics in Prometheus based on the scrape jobs of the services. And as said, we already provide the red metrics out of the box. These are some metrics that we see that are used a lot. So we thought that's something we can automatically generate. So that's basically Captain in a nutshell, where Captain can help you Captain can help you scaling your Prometheus environments by basically just writing SLIs or SLOs that can be reused for different services. And once you apply them, Captain can roll out the configuration to your different Prometheus instances that are hooked to the Captain control plane. I've also blogged about this, so the link is here in the first link. If you have any questions, if you want to join the Captain community, if you want to give it a try, you will find all the information on the Captain website, for example. We have our Captain Git repository that you can check out. Yeah, we have our Twitter link, of course, we have our mailing group. If you want to reach out to me directly, I also put in here my Twitter handle. And with this, I am I'm thanking you for joining this talk, and I'm happy to answer questions.
So we have a question in the comments here, Jürgen, from James. I'll just stick it up there. I've often liked devolving those monitoring alerting config into the teams and co-locating the config in the same repo as the service or app. Is this different for GitOps/Captain?
Let me just take a look here. Co-locating the config in the same repo as the service or app. In our case, it does not live in the same repository as the application code. So the Captain Git repository really holds only the configuration. So the service code itself, like when you're developing your, I think I was talking about the login service. So when you're developing your login service, the configuration doesn't then is not stored in the code repository of the login service, but you will just add the Helm charts and the configuration to Captain, and these are managed in the Captain config repository. So those are two different repositories.
Awesome. So any more questions in the comments, folks? Get them in quick. Let's add Marko back in here as well. Well, I guess if there's no more questions, then we'll start to wrap things up for this evening. So thank you to both of our speakers, Marko and Jürgen, for two great talks. Really enjoyed that, guys. Hope you enjoyed being with us. Thank you to everybody who's been listening on the live stream. Please do subscribe to our channel below, and you can also follow us on Twitter. Let's stick that up somewhere, at Cloud Native MCR. We're going to be back very soon with an event in July. We've already got some speakers starting to line up for that one, so do keep an eye on the meetup.com page, and we'll be announcing that fairly shortly. Thank you to all the organizing team. It's not just me and Nick, the front men. There is a band of of other folks in the background, so thank you to them and to all of our employers for supporting us. So D2IQ, Rancher, Book and Go, Soft Iron. I think that's everybody at the minute. And I guess thank you, Drew. Thank you for both sessions. Both presentations were excellent.
So there was an earlier question from John about getting started, which is probably quite a big conversation. So I think part of the plans for one of the future meetups, Matt, was that we'd try and have a bit more of a 101 getting started type talk. Possibly getting Nigel back for something like that.
Folks lined up who can do that stuff. And I mean, the other thing, as we've said before with these meetups, we've certainly said it in person, is, we are happy to be led by the community as well, and what things people would like to have talks on. So if there is something in the cloud native or Kubernetes world that folks really want to know about, even if that's 101 type sessions, please do let us know, either on Twitter or on the meetup.com discussion page, and we'll try and reach out to the community and find some folks to come and deliver that content.
Or the Slack. There is a Meetup Manchester Slack channel on the Kubernetes Slack if you're not already on there. So feel free to swing by and suggest some topics for further meetups, or indeed suggest a talk for yourself. Yeah, absolutely. And our GitHub repository is the mechanism for suggesting talks. If you'd like to come on either the virtual show or when we get back to doing things in person, just raise an issue on the GitHub repo. I think, have we got a link to that on the meetup.com page? Yeah, I think maybe. We do. Yeah. I'm not sure that professional, but that is the submission channel of choice. In fact, Jürgen was the first one to raise an issue proposing the talk. So
yeah, it was all GitOps. It was working perfectly.
exactly. Could have automated the whole thing. Then you wouldn't even need me in mind. It'd be great.
Okay, are we all done for this evening?
Yeah, looks that way. Thanks again, all.
Yeah, thanks, folks, and we'll see you next time.
Thanks for having us.
Cheers.
Bye.
Bye-bye.